Hi everyone! In the last video we talked about the sum and difference of functions. In this video we're going to take the next natural step, which is to talk about the product and quotient of functions. But let me just remind you, we obtained a new function, f plus g of x, from two functions f of x and g of x by just adding those two functions together. So I gave you an example where f of x represented the amount of pumpkins Annie could pick, g of x represented the amount of pumpkins that Bob could pick, and so the amount of pumpkins they could both pick was the sum of those two functions. Similarly, if you wanted to compute the difference of functions, maybe Bob is stealing Annie's pumpkins or something like that, then we just take f of x and subtract from it g of x, and it gives us a new function which we just call f minus g. These are just new names for the combination of these two functions. We also talked about how to compute the domain of the function f plus or minus g, and that was just the intersection of the domain of f with the domain of g. So I'm denoting this dom f and dom g, and that's what I'll be using in the rest of the videos. So this just said take the restrictions on the function f and take the restrictions on the function g and combine them to get the restrictions on the function f plus g or f minus g. And that's just because these functions are defined by using the old function. So whatever values we plug in to f plus g of x have to make sense to plug into f and to plug into g. Same idea is going to be true for the product and quotient. So let's say I want to multiply two functions together to get a new function. I call that function f times g of x, and I get it by doing f of x times g of x. If I want to take the quotient and to get a new function, I denote that by f over g of x, and I get it by just doing f of x divided by g of x. So by plugging in a value into each function and then either multiplying, dividing, adding, or subtracting, these are called pointwise operations. It basically means we only need to know what the function is doing, what each function is doing at a point to figure out what it's doing at that point for the combination of those functions. Here's what I mean. Say we know f of 2 equals 17 and g of 2 equals 2, but we don't know what's going on for any other value of x. We only know what's going on at 2. I can figure out what the product is at the value of 2 and the quotient at the value of 2, but I can't figure out the product or the quotient at any other value. So let's see how this works. F times g of 2, by the definition, is just going to, so f times g of 2 is just going to be f of 2 times g of 2. F of 2 times g of 2, which is just 17, that's f of 2, given to us, times 2, g of 2. And that's 34. So all I need to know is what the value of f is at 2, what the value of g is at 2, and that tells me what the value of f times g at 2 is. Similarly, to find f over g of at 2, I just do f of 2 divided by g of 2, and that's 17 divided by 2, which is 8.5. Now let's move on to a slightly trickier one. I want to know what's happening for every value of x. So I just use the definition. To do f times g of x, all I need to do is multiply the function f of x by the function g of x. So I have 1 over x times 1 over x squared, and that gives me 1 over x cubed. Easy enough. Let's scroll down a little bit. To do the quotient, f over g of x, I do the exact same thing. I do 1 over x, which is f of x, and 1 over x squared, which is g of x. How do I divide by a fraction? I have to multiply by the reciprocal. So I flip the bottom. X squared over x is just x. So that's all there is to it. It's really not too tricky. Now, when we talk about the domain of the product or the quotient, it's very similar to when we talked about the domain of the sum or the difference. So let's talk about the product first. To get the domain of f times g, this is just going to be exactly how we computed it before, the intersection of the domain of f with the domain of g. For the quotient, however, we need to be a little bit more careful, because what if g of 2 equaled 0 in this example above? Where did my cursor go? There we go. If g of 2 equaled 0, then I couldn't compute f over g of 2. So I need to make sure that the function, that the value I'm plugging in makes sense to plug into f, it makes sense to plug into g, but since g is now in the denominator, I can't plug in values that make g equal to 0. So that's the only additional thing to note. So it's still going to be the intersection of the domain of f with the domain of g, but also we'll need to exclude the values that make g equal to 0. So values of x that make g of x equals 0 from the domain. So let's do an example of this to make sure that it all makes sense. So I want to find the domain of f over g of x if f of x equals x minus 2 and g of x is the square root of x plus 2. So the domain of f is just going to be all the values for x that make this make sense. I'm not allowed to plug in 2 because that would make the denominator of f equal to 2. So the domain of f is x not equal to 2. So if I think about this on a number line, I have 2 here. I can't include 2, but I could include anything else. The domain of g, well, I have a square root, so I know what's underneath the square root has to be greater than or equal to 0. So if x plus 2 has to be greater than or equal to 0, this tells me that x has to be greater than or equal to negative 2. So if here's negative 2, then for the domain of g, I'm allowed to include negative 2 and anything bigger. But now, I also have to exclude the values that make g of x equal to 0. So g of x equals 0 when? If x equals negative 2. So exclude the value negative 2. So now this becomes an open circle as well. So what's my domain? It's everything bigger than negative 2, strictly bigger than negative 2, and excluding 2. So the domain of f over g is x strictly bigger than negative 2 and x not equal to 2. Now let's just look at this a little bit more carefully. So f over g of x. I get it by doing f of x and dividing by g of x. So this is going to be 1 over x minus 2 divided by the square root of x plus 2. So if I look at this expression, the top part says x cannot equal 2 because I have x minus 2 in the denominator. The bottom part, because of the square root, I know x has to be greater than or equal to negative 2. But because this whole thing is in the denominator, x can't equal negative 2 either, because that would make the denominator 0. So this restriction is coming from the domain of f, this restriction is coming from the domain of g, and this restriction is because g is now in the denominator. So I put these three restrictions together, and I get this domain. And that's exactly what we're seeing here. We take the restriction from f, the restriction from g, and we make sure that g does not equal 0, and combine all those rules together to figure out the domain. Good luck with the problems, and I'll see you next time.